All right, so this is the review for the test. For number 1 here, I would just multiply straight across. Since it's a multiplication sign. So let's see. Right here, if I need this. So 6 times 3 is 18. X squared times x is x to the third. Then I have z to the fourth. 7 times 4 is 28. There's an x, y to the fifth, 4 plus 1 is 5, and z squared. All right, if you want to reduce 18 over 28, if you can do it in your head, obviously, hopefully we know that it is, give me one sec here, this is just a tad bit. All right, 18 over 28, you can reduce both by 2, but if you couldn't do that, you actually do n over d and 18 over 28, and that will reduce it to you to 9 over 14. And then when you divide, you subtract, so x cubed or x, so 3 minus 1 is 2, so x squared. There is no y except on the bottom, so I'm going to leave that one alone. And then z fourth over z squared is z squared. All right, for number 2, once again, multiply straight across, since the multiplication sign, so there's a 3 at the top. A to the negative 2 times a to the fifth, so that's 5 plus negative 2, which is just 3. And then we have c to the fourth. 7 times 4 is 28. A, b to the fourth times b to the negative third, so 4 plus negative 3 is 1. And then c squared. And now we reduce. 3 over 28 cannot reduce. A cubed divided by a to the first is a squared. There's no b except on the bottom. C to the fourth divided by c squared is c squared. All right, for this next one here, first, since it's division, I would flip the third one over. And while I'm doing that, I'm also going to distribute this 3. So 3 times 1 is 3. 3 times 1 is 3. And 3 times 1 is 3. And notice I am flipping it over. Now I'm just going to multiply straight across. So 3 times no other number is just 3. X squared, x to the third, x to the sixth. Y to the third, y to the fourth, y to the fifth, sixth, seventh. And then we have z cubed. Over, so I only have a 4 at the bottom. X is x to the fourth, x to the sixth, y to the 5, 6, 7, 8, 9. And z to the 2, 3, 4, 5, 6, 7. And now we just simplify. 3 on the top, 4 on the bottom. X over 6 cancels out, reduces to 0, so x is 0 plus 1, we don't need that. 7 minus 9 is negative 2, but since it's a negative exponent, we're going to move it to the bottom. 3 minus 7 is negative 4, so when we put z to negative 4, we have to move it to the bottom, so it becomes z positive 4. And there's my answer. All right, on to 4 and 5. So here we're just going to factor completely. So this, it's a multiplication sign, so we're going to factor top left, top right, bottom right. So this is going to factor to x plus 7, x minus 7. This one factors to x plus 7 squared, but since I'm going to be canceling out, I'm going to write it separately. Times x plus 5, x plus 7. And x plus 5, x minus 5. Extend my division bar, and now I'm going to cross out things that can cancel. So starting from the top left, I see x plus 7s on top of each other, so I can cross those out. I don't see an x minus 7 on the bottom. I see an x plus 5, and I see another x plus 7. So remaining in my numerator is x minus 7, and my denominator is x minus 5, and that would be my final answer. right, for number 5, we'll follow the same process here. Let's use. So I'm going to factor the top left. That looks like x plus 2 and x plus 1. Let's try that again. X plus 2 and x plus 1. That one's running out too. So this would be x plus 3, x plus 2, times, this one looks like x plus 3, x plus 4, and x plus 4, x plus 1. Extend your division bar. So it looks like x plus 2 is on the bottom, x plus 1 is not, x plus 3 is on the bottom. Oh, actually, x plus 1 is on the bottom, and x plus 4 is at the bottom. So everything cancels out. What's remaining is 1. All right, on to number 6. Division means to flip it over and multiply. So the second one, we're flipping it over and multiplying. From here, now we do exactly what we did on number 4 and 5. We factor. Alright, and then we extend our division bar. Since we're multiplying, we cancel out our common factors here. So x plus 3 is at the bottom. X minus 3 is not. X plus 3 is not. X plus 4 is. And x minus 4 is not. So let's make sure. X plus 3, x minus 3, x plus 3, x plus 4, x plus 4, x minus 4, x minus 4, x plus 3. All right, so from here, it looks like we have, as our final answer, x minus 3 times x plus 3 divided by x minus 4 squared. And once again, you could always multiply those out if you wanted to. You could FOIL it out and get x squared minus 9 over x squared minus 8x plus 16. You could also do that if you wanted to. For number 7, this one I'm just going to go straight into working it out. So I'm going to factor this. So x plus 5, x plus 4, x plus 4, x minus 4. From here, I'm going to multiply, and I'm going to factor while I flip it. So this is going to go to the top, and this one will move to the bottom. So this becomes x plus 3, x plus 4, x plus 4, x minus 3. Extend this and cross out my common factors. So here, x plus 5 is nowhere on the bottom. X plus 4 I can see here and here. X plus 3 is not on the bottom. X plus 4 again is here and here. So 2 ways to write this answer. What's left on the top is x plus 5 times x plus 3 divided by x minus 4 times x minus 3. So I'll accept this answer, or if you want to FOIL it out, x squared plus 8x plus 15 divided by x squared minus 7x plus 12. All right, moving on. Number 8. So here, it's adding or subtracting now. So first thing we're going to do is we're going to find our LCD. So I'm going to factor this, x plus 9, x plus 4. So I see they have x plus 9 in common. And what's not in common is the x plus 4. So when I look at this, I can see that this one has both of them, so I don't have to worry about adding an LCD here. But this one has the x plus 9, and it's missing the x plus 4. So I'm going to multiply the top and the bottom by x plus 4. From here, we're going to distribute it. 5 times x is 5x. 5 times 4 is 20 over the LCD. Plus, this is just x plus 3 on the numerator over the LCD. Now I can combine my like terms on the top. 5x plus 1x is 6x. 20 plus 3 is 23 over the LCD. Now, I look at this point, I cannot factor anything out, so then my final answer would be 6x plus 23 divided by x plus 9 times x plus 4. And I'm going to move this LCD over here so it's not in the way. All right, for number 9. All right, so for this one here, I'm going to break this down into small factors. So this is 2 times x. This is 2 times 3 times x times y, and this is 3 times y. So for my LCD, what do they have in common? Well, I see they have a 2 in common. I see they have the 3 in common. I see they have an x in common. And I see they have a y in common. So they actually have everything in common. So if you multiply those out, your LCD is actually 6xy. Okay, so right here, if I look here, the first one, it has the 2 and the x, so it's missing the 3y. So I'm going to multiply the top and the bottom by 3y. This one has everything. It has the whole 6xy. This last one has the 3 and the y. It's missing the 2x. Now, one thing I noticed, the positive is fine, but these minus signs, I don't like to forget them, so I switch this to a plus, and on the top right, I switch that sign. Okay, from here, we're going to multiply. 3y times 5 is going to be 15y over the LCD, and this one's pretty short, so I'm just going to write 6xy, plus, this one didn't need anything, so 6 over 6xy, plus negative 4 times 2x is negative 8x over 6xy. Now I look to see if I can combine like terms. None of these are the same, so I'm just going to put them in alphabetical order. Negative 8x plus 15y plus 6 over 6xy. And I can't factor anything out. I can't take out a common factor because they're not all divisible by something. So this will be my final answer. All right, on to number 10. So once again, I see that minus sign, so I'm going to change it to a plus and then change the top right signs. All right, so here, LCD. I'm going to factor this, x plus 5, x minus 5, and we're just going to cross it out so we don't get confused. So my LCD, what do they have in common? They have x plus 5. What's not in common is this x minus 5. So if we take a look here, we notice the second one has both x plus 5 and x minus 5. And the first one only has the x plus 5, so we need to multiply the numerator and denominator by x minus 5. So now we're going to distribute. 2 times x is 2x, 2 times negative 5 is negative 10 over the LCD, plus negative 3 over the LCD. Next thing we do is we combine like terms. So 2x, negative 10 plus negative 3 is negative 13. And at this point, I see that I cannot factor this. There's no GCF, so now I'm going to write the LCD of x plus 5 times x minus 5. Nothing cancels. So that would be my final answer. All right, moving on to number 11. So here, once again, change this to a plus, flip the top signs on the right. LCD, they have nothing in common actually, but I see what's not in common is x plus 3 and x plus 4. So this one has x plus 3, it needs the x plus 4. This one has x plus 4, it needs the x plus 3. So here I can do 4 times x is 4x, 4 times 4 is 16 over the LCD, plus negative 2 times x is negative 2x, negative 2 times 3 is negative 6 over the LCD. Now I can combine like terms, 4x plus negative 2x, or 4x minus 2x is 2x, 16 plus negative 6, which is 16 minus 6, which is positive 10 over the LCD. So from here, I see I can factor out a 2, leave me with x plus 5, divided by, and now here we're going to do LCD, which is x plus 3 times x plus 4. Nothing in common they can factor out, or can cancel out, so there's my final answer. Now once again, with all these, if you want to multiply it out, you can, but I'm just going through this here. On the previous answer key I sent, I worked out this problem, so I'm going to work out number 13 now. So the way you should go about doing this is like this. So first off, we're going to do each of these fractions independently. So I'm going to do this one first. So 3x over 2x minus 1 minus 2, I'm going to make it a fraction by putting it over 1, divided by, and then we'll do this one, 5 divided by 4x minus x over 2x minus 1. Since the minus sign, switch that and make that negative, and same up here. Switch this sign, make this one negative. Okay, so I'm going to treat this one first. So here I notice it's a 1 and a 2x minus 1, so the LCD is just 2x minus 1, which means this has 2x minus 1, but this one needs to be multiplied in the numerator and denominator by 2x minus 1. So this would be 3x over 2x minus 1 plus, now we distribute, negative 2 times 2x is negative 4x. Negative 2 times negative 1 is positive 2 over 2x minus 1. Now we notice our LCDs, our denominators are the same. So now we can combine the tops. 3x minus 4x is negative x plus 2 over my LCD, which is 2x minus 1. Now in the denominator, we're going to simplify this. So here I see they have nothing in common. So the LCD is 4x and 2x minus 1. So this one needs a 2x minus 1 in the numerator and denominator. And this one needs a 4x. Okay, so from here, distribute. 5 times 2x is 10x. 5 times negative 1 is negative 5 over the LCD. Plus negative x times 4x is negative 4x squared over the LCD. So we see we have a common denominator now. So we can add the tops, and nothing actually combines, so it's going to be negative 4x squared plus 10x minus 5 over the LCD of 4x times 2x minus 1. So from here, this is just a division problem. So I'm going to rewrite it so how you're used to seeing it. So I'm going to write it as negative x plus 2 divided by 2x minus 1 divided by negative 4x squared plus 10x minus 5 over 4x times 2x minus 1. And as you recall, when we solve these, all we do is we flip the second one over and multiply. So negative x plus 2 divided by 2x minus 1 times 2x minus 1, and now rewriting the bottom now. And extend this, and hopefully you can see the only thing that cancels out is the 2x minus 1s. So now I'm okay with my final answer being 4x times negative x plus 2 over the denominator of negative 4x squared plus 10x minus 5. And nothing else can be reduced. Oh, there you go. And moving on from here. Now we're on to the solving. So it says solve the following rational equations, show all work, give both the solution and the domain constraints, which is pretty much the domain restrictions. All right, so first off, this is going to be a fraction. So my LCD here would be, let's see, LCD will be x minus 3, because that's what's not in common. There's nothing in common. So my domain restriction, x cannot equal to 3. So I'm going to put the LCD above each one, so x minus 3 above here, and x minus 3 above here. So here I see nothing cancels, so I'm going to do 2 times x minus 3 equals, here I see they both have an x minus 3 on the top and the bottom, so I cross that out, leaving me with x plus 2. So I'm going to distribute this, so 2x minus 6 equals x plus 2. I'm going to subtract the x here, which leaves me with x. I'm going to add the 6 here, which leaves me with 8. So x equals to 8. Check your domain restriction. X cannot equal 3. It does not, so that answer is good. All right, for number 15, LCD, they have nothing in common. What's not in common is 3 times x plus 7. So my domain restriction, x cannot equal negative 7. Now in this case, it cannot equal 0 because 3 does not have a variable with it. So we put the LCD above each one. And we cancel. Here I say and cross out the 3's. So x times x is x squared. X times 7 is 7x. Here I can see I can cross out the x plus 7s. So 3 times negative 2 is negative 6. Since it's a quadratic function, we're going to set it equal to 0 by bringing the minus 6 over, so adding it. We're going to factor this to x plus 6, x plus 1. And now we solve it. X equals negative 6 and x equals negative 1. It does not equal negative 7, so both these answers are good. All right, for number 16, LCD, they have nothing in common. What's not in common is x and x minus 2. So my domain restriction is x cannot equal 0 and positive 2. So I put that above each one. And once again, if you want to cross multiply, feel free to. Here I see the x minus 2's are in common, so I cross those out. So x times x is x squared. X times 1 is positive x. Here we can cross out the x, and you have to FOIL this one out. So x times x is x squared. Negative 2x minus 3x is negative 5x, and negative 3 times negative 2 is 6. I'm going to subtract x squared from both sides, and now we have x equals negative 5x plus 6. Add the 5x over. So 6x equals to 6, divide by 6, and we see that x equals to 1. We check our restriction, cannot be 0 or 2, so x equals 1 is a good answer. All right, on to number 17. So we have this two fractions here. So for my LCD, they have nothing in common, which negative 3 and x plus 2 is what's not in common. So my domain restriction, x cannot equal negative 2. Put your domain above each one. Cancel out the commons. This I can cancel out the negative 3. So this is two binomials. So x squared minus 3x minus 10 equals here. The x plus 2 cancel out, so it's just negative 12. Bring this over so that it's set equal to 0. So x squared minus 3x plus 2 equals 0. Factor this. X minus 2, x minus 1 equals to 0. Solutions, x equals 2 and 1. X cannot equal negative 2, so both answers are good. All right, for 18, LCD, what they have in common is the x. What's not in common is the 2. You can put this over 1. 1 doesn't really affect anything. So my domain restriction here, x cannot equal 0. So he sets 2x equal to 0, divide by the 2, and x equals 0. So we put the LCD above each one. Here I can cross out the 2's. So 3 times x is 3x. Here I can cross out the x's. So 2 times 1 is positive 2. Here nothing cancels out, so 2x times 1 is 2x. X's cancel out. 2 times 4 is 8. Subtract the 2x and subtract the 2. So 3x minus 2x is x. 2 minus 2 is gone. 2x minus 2x gone. 8 minus 2 is 4. Check it against the restriction. Cannot equal 0. The answer looks good. All right. Let's see. Give me 1 sec here. Oh, 8 minus 2 is not 4. 8 minus 2 is 6. Sorry about that. Something looked a little off. All right, number 19. Factor this first. X plus 3, x minus 3. So my LCD here, they have x plus 3 in common and x minus 3. So therefore my domain restriction, x cannot equal plus or minus 3. Let me move this over here so you can actually see what I did. There you go. Okay, from here, put the LCD above on top of each one with the numerator. All right, from here, I see the first one I cross out x minus 3. So 4x and 12. Second one, I can cross out x plus 3. So 2x minus 6. Here, everything cancels, leaving me with 2x plus 2. So here, 4x plus 2x is 6x. 12 minus 6 is 6. Subtract the 2x, and I'm going to subtract the 6. So 6x minus 2x is 4x. 6 minus 6 goes away. 2x minus 2x goes away, and 2 minus 6 is negative 4. Divide by 4. x equals to -1. My restriction says cannot equal plus or minus 3, so the answer looks good. All right, for number 20, put these over 1. LCD, they have just the x in common, and the 1s don't affect anything. So my domain restriction, x cannot equal 0. So we're going to put the LCD above each one. Here, nothing cancels, so 1 times x is x. Here, the x's cancel, so it's just plus 6. Here, the x's cancel, so it's 2x minus 4. And here, nothing cancels, so 3 times x is 3x. So x plus 6, we're combining our like terms. 2x plus 3x is 5x. I'm going to subtract the 5x. I'm going to subtract the 6. So 1x minus 5x is negative 4x. 6 minus 6 goes away. 5x minus 5x is 0. Negative 4 minus 6 is negative 10. Divide by negative 4. X equals positive 10 over 4, but we can reduce that to 5 halves. X cannot equal 0, so this answer is good. All right, next problem. I see a minus, so I'm going to switch that to a minus there. Okay, so 2x minus 1, 2x plus 1. This is a difference of two squares, 2x plus 1, 2x minus 1. So for the LCD, I can see 2x plus 1 is the same, and so is 2x minus 1. If you set each one of those equal to 0, x cannot equal negative 1/2 and positive 1/2. All right, so we put that above each one. So here, 2x minus 1 cancel. So that's 2x squared plus x. This cancels, so negative 4x plus 2. And this one, everything cancels. So it's just equals x squared plus 20. So here we have 2x squared. X minus 4x is negative 3x plus 2 equals x squared plus 20. I'm going to bring everything to this side, so I'm going to subtract x squared. And I'm going to subtract 20. So x squared minus 3x plus 18 is equal to 0. So x minus 6, x plus 3 is equal to 0. So x is equal to 6, and negative 3 does not go against my domain restriction, so both answers are good. All right, and do we have anything else? Let's see. All right, and here's just some extra factoring problems if you need help. So let's see. Let's put some directions here. Just directions will be just factor. So if you need help with factoring, like here's one of them. 2x squared plus 6x. So here, GCF is 2x, and leaving me with x plus 3. Another one. These are just GCF common factors, so x squared plus x. You can factor out an x, leaving you with x plus 1. A third one, 3x plus 12, so the GCF here is 3, leaving us with x plus 4. So just some basic GCF type factoring problems. Some other ones, let's see. X squared plus 5x plus 6. So here you can do the x method. So 5 on the top, dividing by my a value of 1. Don't forget to multiply a times c, so 1 times 6 is 6. So two numbers that add to 5 and multiply to 6 is going to be 3 and 2. So that would be x plus 3, x plus 2. The next one, number 5, let's go with x squared plus 6x plus 5. So these are just some example factoring ones. 6 on the top, a value is 1. 1 times 5 is 5. So factors that add to 6 and multiply to 5 are going to be 1 and 5. So that's going to be x plus 1, x plus 5. All right, let's get to some ones that will definitely help you. Let's say this one here, just remembering how to factor when a is not equal to 1. So here, 7 on the top. A value is A value is no longer 1, so we're going to divide by 2. A times C, so 2 times 5 is 10. So two numbers that add to 7 and multiply to 10 are 5 and 2. So 5 divided by 2 does not reduce or anything, so it's going to be 2x plus 5. And 2 divided by 2 is 1, so x plus 1. Let's go with another one. Number 7 here. So for this one here, we have, let's see, 7x squared minus 9x plus 2. So here, negative 9 on the top, dividing by my a value of 7. 7 times 2 is 14. So two numbers that add to negative 9 but multiply to 14 are going to be negative 7 and negative 2. Negative 7 divided by 7 is 1, so that's x minus 1. And this does not reduce or anything, so 7x minus 2. And for the last one, 15x squared minus 7x minus 4. Factors would be negative 12 and 5. This reduces to 1/3. This reduces to negative 4 over 5. So this would be 5x minus 4 and 3x plus 1. All right, that's it.